I'm Dr.N.Ramya, Associate Professor in Department of Mathematics, Bharat Institute of Higher Education and Research. Subject name is Advanced Calculus and Algebra. Subject code U20Mabt02. The topic is going to be covered in vector calculus. In this topic, differential operator, gradient, divergence, solenoidal vector, irrotational vector, curl of vector, Green's theorem, Gauss divergence theorem, and Stokes theorem has to be covered. The scalar point functions. At each point P of a region R, we may associate a scalar. Then that is a scalar point function over the region R. Next, vector point function. If to each point P of a region R is associated with the vector F vector is called vector point function. Then the differential operator. Del is a differential operator. It is denoted by I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Here I vector, j vector, k vector are the unit vectors along the three axes, x axis, y axis, z axis. Del square, the square of del, that is del dot L equal to dou square by dou x square, dou square by dou y square, dou square by dou z square is a Laplacian operator. Next, find del of R and del of 1 by R. Solution, R vector, that is another name is position vector. R vector equal to xi vector plus yj vector plus zk vector. The position vector R vector, then modulus of R vector is equal to root of x square plus y square plus z square. And squaring on both sides, we can get R square is equal to x square plus y square plus z square. Differentiate on both sides, it become 2r, dou r by dou x equal to x by r. Then dou r by dou y equal to similarly y by r. Then dou r by dou z equal to z by r. Then del of r is equal to I vector dou r by dou x plus j vector dou r by dou y plus k vector dou r by dou z, which is equal to I vector dou r by dou x value is x by r, dou r by dou y is y by r, dou r by dou z is z by r. So we got del of r. Here the denominator is same, and then we can add the numerator. It become xi vector plus yj vector plus zk vector whole by r. That is equal to r vector by r. So del of r is equal to r vector by r. Second one, del of 1 by r is equal to summation I vector of dou by dou x of 1 by r. Summation I vector, then differentiation of 1 by r with respect to x is minus 1 by r square. Again we have to differentiate the r, that is dou r by dou x. So minus 1 by r square, we can take an outside of the summation, it become summation xi. Summation xi can be written as xi vector plus yj vector plus zk vector, that is equal to r vector. So already we are having r, that is r cube. So del of 1 by r is equal to r vector by r cube. Find the directional derivative of phi is equal to x square yj plus 4xz square plus xyz at 1, 2, 3 in the direction of 2i plus j minus k. First phi is given by, that is x square yz plus 4xz square plus xyz. Del phi is denoted by I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Now differentiation of phi with respect to x, we can get 2xyz plus 4z square plus xyz. Similarly, differentiation of phi with respect to y is x square z plus xz. And differentiation of phi with respect to z is x square y plus xzz plus xy of k vector. Now at the point of contact is 1, 2, 3. So in the place of x we have to substitute 1. In the place of y substitute 2. Then z by 3. After substituting this, we got 54 I vector plus 6j vector plus 28k vector. And another in the direction is given by 2i vector plus j vector minus k vector. And taken the modulus of this, it become root of 2 square plus 1 square plus 1 square. That is, it become root 6. Now we need to find the directional derivative. The direction derivative is represented by del phi dot a vector by modulus a vector. So del phi is here. We got 54i vector plus 6j plus 28k vector dot a vector by modulus a vector. A vector is given in the question, that is 2i vector plus j vector minus k vector by root 6. Then we have to multiply by I with I, j with j, k with k. So here I dot I is 1, j dot j is 1, similarly k dot k is 1. After multiplying these things, we got 86. Already we are having root 6. So the directional derivative is 86 by root 6. Next, unit normal vector. Unit normal vector is denoted by n cap. N cap is equal to del phi by mod del phi. First problem, based on the unit vector, to the surface x square plus y square minus z equal to 10 at a point 1, 1, 1. So phi is given here. So del phi is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. That means we differentiate the phi with respect to x, with respect to y, with respect to z. So first we have to differentiate with respect to x. We got 2xi. Here that is differentiate this one with respect to y, that is 2yj. Then with respect to z we got minus 1, that is minus k vector. But the point of contact is 1, 1, 1. So in the place of x, you have to substitute x, y, z. We got 2i vector plus 2j vector minus k vector. So mod del phi is equal to root of 2 square plus 2 square plus 1 square. It become root 9, that is equal to 3. But unit normal vector n cap equal to del phi by mod del phi. So we are having del phi is 2i vector plus 2j vector minus k vector by 3. Next, divergence f and curl of how to find. For the given f vector is equal to gradient of x cube plus y cube plus z cube minus 3xyz. So f vector is, that is gradient is represented by del of x cube plus y cube plus z cube minus 3xyz. So now we have to differentiate with respect to x, with respect to y, with respect to z. So we got 3x square minus 3yz into I vector plus 3y square minus 3xz into j vector plus 3z square minus 3xy into k vector. Now divergence f is del dot f, that is del is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. So here I dot I 1, j dot j is 1, k dot k is 1. So differentiate with respect to x here, dou by dou x of 3x square minus 3yz into I vector. So dou by dou y of 3y square minus 3xz plus dou by dou z of 3z square minus 3xyz. So after differentiating, we got 6x plus 6y plus 6z. So this is a del dot f or divergence f. Second one is curl f. The curl f is denoted by del cross f. Del cross f is equal to determinant I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. Next f vector is 3x square minus 3yz, 3y square minus 3xz, 3z square minus 3xy. So now we have to calculate the corresponding column, corresponding row. I vector of, we got minus 3x plus 3y minus j vector of minus 3y plus 3y plus k vector of minus 3z plus 3z. So after calculation, we got 0 vector. So this is a del cross f vector. Next curl of a vector is A is an axial vector whose magnitude is the maximum circulation of A per unit area tends to 0 and whose direction is the normal direction of the area when the area is oriented so as to make the circulation maximum. Next, curl of a vector in Cartesian coordinate. Del cross A is equal to, it can be denoted by also determinant AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z. Here AX, AY, AZ. This del cross A is denoted by this way also. So here AX of corresponding column, corresponding row. So dou by dou Y of AZ minus dou by dou Z of AY. The second term is always negative. So minus of AY of corresponding column, corresponding row, dou by dou X of AZ minus dou by dou Z of AX plus AZ into corresponding column, corresponding row. So dou by dou X of AY minus dou by dou Y of AX. So this is a del cross A in the Cartesian product. Next important theorem, Green's theorem. The Green's theorem gives the relationship between the line integral of the two-dimensional vector field over a closed path in the plane, the double integral over the region it encloses. Next, in the fact, the integral of the conservative field over a closed path is 0. This is a special case of Green's theorem. Green's theorem is integral over C p dx plus q dy is equal to double integral over R dou q by dou x minus dou p by dou y. Next, the Green's theorem in the plane. This statement we can represent by another way. U, V, dou E by dou x, dou E by dou y are the continuous and single valued function or one valued function in the region R and enclosed in the curve C. Then integral over C u dx plus v dy is equal to double integral over R of dou v by dou x minus dou v by dou y into dx dy. So this is a Green's theorem in the plane. Now we have to verify the Green's theorem through an example. So verify Green's theorem in the xy plane. Integral over C xy plus y square dx plus x square dy. In the closed curve C, the region is bounded by y equal to x and y equal to x square. So the Green's theorem in the xy plane is integral over C u dx plus v dy is equal to double integral over R dou v by dou x minus dou v by dou y into dx dy. So here u is equal to xy plus y square and v is equal to x square. Now we have to differentiate with respect to y. Here it becomes dou u by dou y equal to x plus 2y. Similarly, dou v by dou x equal to 2x. Now this left hand side consists of two parts. One is along OE, that is along y equal to x square, and the second one is along AO, that is along y equal to x. So first you have to consider along OE, that is y equal to x square. Here y equal to x square means just you have to differentiate this, it becomes dy is equal to 2x dx. So we have to replace in this one, the left hand side, replace y by x square and dy by 2x dx. It becomes x of x square plus x square the whole square dx plus x square into 2x dx. After simplification this, x cube plus x power 4 dx plus 2x cube dx. We have to arrange the term, it becomes 3x cube plus x power 4 dx and integral. We have to integrate with respect to x. After integration and substitution the limits, we got 19 by 20. This is for along OA. Next, along AO, the line equation is y equal to x, which implies dy equal to dx. So along AO, that is, we have to replace in the place of y is x, in the place of dy is dx. After doing that, we got x square plus x square of dx plus x square dx. It becomes 3x square dx. You have to take the integration of this, it becomes 3x cube by 3. So 3 get cancelled. We have to substitute the limit, we got the minus 1 is the value. So now together we have to add the both. So it becomes, we can get the whole left hand side. So along OA plus along AO. So along OA already we got 19 by 20. Along AO is minus 1. So after taking the LCM we got minus 1 by 20. Next, similarly the left hand side is double integral over R dou v by dou x minus dou u by dou y of dx dy. So double integral over R dou v by dou x minus dou u by dou y into dx dy So dou v by dou x value is 2x. Then dou u by dou y is x plus 2y. Now the integral limit is the inner integral, that is y to root y. The outer integral is 0 to 1. First of all, we have to integrate with respect to x. It becomes x square by 2 minus 2yz y to root y. We have to substitute the limit. Again, we have to take the integral with respect to y. We have to substitute the limit. So after substitution will be over. The value is minus 1 by 20. So already we got the left hand side is minus 1 by 20. Similarly, right hand side also minus 1 by 20. So in this problem, the Green's theorem is verified. Next, second theorem is Divergence Theorem. The Divergence Theorem states that the total upward flux of a vector field A at the closed surface S is the same as the volume integral. It is represented by integral over V A dot ds is equal to integral over V del dot A into dV. This is a divergence theorem. Now by using the divergence theorem, see the example here, f vector is equal to ax I vector plus by j vector plus c z k vector. Here a, b, c are the constant. But we have to show that double integral over s f dot n cap into ds is equal to 4 pi by 3 of a plus b plus c. So Gauss divergence theorem statement is double integral over s f dot n cap ds is equal to double integral over v del dot f dv. So any one of the part we can find either the left hand side or right hand side. So here first of all we have to consider this as del dot f we have to calculate. So del vector is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by ds. Now we have to take the dot product, that is a divergence f. After the dot product we have to take, that is double integral over b dou by dou x of ax plus dou by dou y of by plus dou by dou z of cz. Before integration, that is we have to take the constant term outside. A constant term is a, b, c. So that is a plus b plus c. We can keep outside. Remaining double integral over b dou x by dou x. Similarly, the second term dou y by dou y. Third term dou z by dou z. Now it become as 1. So double integral over v dv. Actually, what is a v? V is the volume of the unit sphere. The sphere volume, the formula is 4 by 3 pi r cube. So now a plus b plus c. So we can represent double integral over v dv as capital V. So capital V is the volume of the sphere. So 4 by 3 pi, here r is 1. So we can substitute in this 4 by 3 pi of 1 cube. It become 1. So now double integral over s f dot n ds is equal to 4 pi by 3 of a plus b plus c is proved. This is an example of the Gauss divergence theorem. The third one is the Stokes theorem. Stokes theorem for f vector is equal to x square plus y square of I minus 2xyj taken around the rectangle bounded by the lines x equal to plus or minus a, y equal to 0 and y equal to b. Solution. The Stokes theorem statement is integral over c f dot dr is equal to double integral over s del cross f vector dot n cap into ds. So first you have to calculate this right hand side because it consists of only one part, single part. So now first f vector is given in the question. We got to find the del cross f vector, that is equal to determinant I vector, j vector, k vector. Then del is, that is dou by dou x, dou by dou y, dou by dou z. Then f vector is given in the question. So xk plus y square minus 2xy. Here no k term, so instead of that you put 0. After simplification, this I vector of the corresponding column, corresponding row, the term become, first term becomes 0. The second term minus j vector into corresponding column, corresponding row, the second term also 0, but the third term we got minus 4yk. Now we have to take the integral, double integral over s del cross f vector dot n cap into ds. So double integral over s, del cross f is minus 4 by k vector dot n cap is here k vector into dx dy. But k dot k is 1. So we are having only minus 4y dx dy. Minus 4 is a constant here. So we can take an outside of the integral. So minus 4 of 0 to b minus 80. These things are limits are given in the question y into dx dy. First we have to calculate the inner integral with respect to x. Then how to substitute the limits. Then we have to calculate the outer integral value. So we got minus 4ab square. So the right hand side is minus 4ab square. Similarly, we have to prove the left hand side also the same. So f factor, given f factor is x square plus y square of I minus 2xyj. So f dot dr, because the left hand side consists of, it has 4 parts, because this is a rectangle. Rectangle contains the 4 sides. So every side we have to find the integral, single integral. So together we have to add, we can get the left hand side. So first in f dot dr you have to calculate. F dot dr is equal to integral over c x square plus y square of dz minus 2xy dy. So first along integral over c is equal to integral ab plus integral over bc plus integral over cd plus integral over de. First you have to calculate the integral along ab. Here integral along ab is equal to of, that is ab of x square plus y square dx minus 2xy dy. Along AB, the side is y equal to 0, which implies dy equal to 0. So now y equal to 0 and dy equal to 0, we have to substitute in this integral. We can get here x square dx. Then after that, we have to integrate with respect to x and substitute the limits. We got 2a cube by 3. The second integral is along BC is equal to integral over BC x square plus y square dx minus 2xy dy. Along BC side, that is x equal to a, which implies dx equal to 0. Now how to substitute the value of x and dx value in this value. Here after substituting this, the limit is here 0 to b is given. So after substituting minus 2ay dy. Now integral with respect to y, it become minus 2a y square by 2. Limit is 0 to b. How to substitute the limit? It become minus a b square. This is second integral value. Next one. Third integral is along CD. Integral over CD is equal to, that is integral over CD of x square plus y square dx minus 2xy dy. So along CD, the side is y equal to b. Y equal to b, which implies dy equal to 0. This two value, y equal to b and dy equal to 0, we got to substitute in the integral. After substituting the integral limit also a to minus a. So I get x square plus b square of dx. That is integral, I have to take the with respect to x. It become x cube by 3 plus b square x. Then upper limit is minus a. Then lower limit is a. After substituting the limit, we got minus 2a cube by 3 minus 2ab square. The fourth integral is along dA. Along dA is equal to, along integral over dA, x square plus y square of ds minus 2xy dy. So along dA, the side is x equal to minus a, which implies dx equal to 0. So x equal to minus a and dx equal to 0, we have to substitute in the integral values. So the limit is integral b to 0. After substitute the value of x equal to minus a and dx equal to 0, we got 2ay dy. Integration with respect to y, that is 2a y square by 2. 2 to get cancelled. So again a y square. We got to substitute the limit. Upper limit is 0 minus lower limit. After substituting that, we got minus ab square. So we obtained all the 4 integral of the left hand side. And together you have to add all the 3. Integral over ab plus integral over bc plus integral over cd plus integral over de. All the things have to add. We got minus 4ab square. So already we got the right hand side is minus 4ab square. Similarly here also the left hand side also minus 4ab square. So here in this problem, the Stokes theorem is verified. Thank you.